All right, here we go. So welcome to fractions. This is my way of teaching in a systematic and multimodal way. And here we go. What to expect from tonight, what is multimodal, and a little bit of brain science, I guess. A lesson demonstration. And it's the actually the very first lesson in the series of lessons. It's what sets it off. I'll talk a little bit about the sequence and progression, and then we'll just take some questions at the end. All right. So why multimodal and not multisensory? We've heard this word multisensory at length. And why I don't like to use, and I like to use multimodal, is because multisensory is too narrow. It only considers the 5 senses, 2 of which we don't usually use for learning. We don't ask children to taste and smell things. We might, depending on what we're teaching, but those 2 are not ones that we engage with in learning usually. So that really only gives us 3 ways of going in to our brain, just 3 pathways. I like to use the word modes because it activates other additional and non-sensory pathways to long-term storage. And I'll talk about that in a minute when we look at the brain. So there's sight, hearing, and manipulating, which is the sense of touch. But on top of that, we're going to be looking at memory, ways to categorize, negotiate meaning, apply knowledge. We're going to be doing imagining, connecting, and of course, talking. And I just want to talk a little bit about what talking means. For us as human beings, the ability to verbally and orally express ourselves is our best tool that sets us apart from all the other animals. It's what has given us the power and strength to sort of evolve to where we are. And language is the way in. Primarily for children. Children are hardwired to learn language and everything about language from zero, from before they're even born. Areas in the brain are wired to learn language, and we often underestimate their ability to learn big words and understand what they mean. And we often say, oh, we're going to, pare that down a little bit, dumb it down a little bit, I guess, is so that they can understand. But we're doing them a disservice because they can understand and perceive language far better than we think as adults. So I'm always a fan of giving them the language, no matter how complex and it may seem to us. So this multimodal is also a cross-curricular approach. And when we talk about curriculum development, we talk about vertical articulation, which is sort of maybe through history or through the scope and sequence. But we also talk about horizontal articulation, which is how wide we can go with something. And why do we do it? Well, we do it because every learner has their own way of taking things in and connecting to them. So the more ways we offer, the more likely they are to hook onto something, to hook that knowledge and bring it in. And when we talk about multisensory, it's only 3 ways, really. There's limitation, but if we engage other parts of the brain, other parts of how we learn, then it's one more way. Every child will have a chance to find at least one way in. That's what I'm trying to say. How the brain learns? Well, ideally, we'd like everything to go into long-term memory first. And that's where we store things. Long-term memory is permanent memory. It's virtually limitless. And children have amazing capacity to learn and remember. And our memory starts to become compromised somewhat as we age, as we get older. So why not take advantage of this amazing time of their life when they can remember so much, and they can hold on to it for life. So aside from long-term memory, we also have short-term memory, which is more temporary. So you can store things that can last just minutes, days, or weeks. Think about cramming information for an exam. We study today to set the exam tomorrow. but we might not remember a week later what we have just studied. So that's one way. Sometimes you'll look in the fridge and you go, oh, I need milk, and you're only going to hold on to that information until you made it to the supermarket to buy milk, and then it's almost a conscious erasing of that memory. It's like a whiteboard. You're putting things in just for a little while, and then when it no longer serves you, then it kind of goes away. This is where we store things that we learn first. So if it's something new, this is where it goes first. And helping short-term memory is this other one that's called the working memory, and this is even shorter, and it's calling information to mind either from long-term memory or from your senses to help complete a task at hand. So, for example, if I need to make a phone call, I need to remember who I'm going to call. I need to remember the number. I need to remember what I want to tell them. Might have a little bit of a plan. So that's all working memory. Somebody might be knocking on the door and distracting me. I need to consider that. Maybe I'm at the same time I'm doing something else. Maybe I'm maybe cooking dinner or something. So all of that is working memory. And it is the play between short-term memory and long-term memory that interaction, it's more than play, that helps newly learned things move on into long-term memory. So basically they sit in short-term memory for a day to a week. And then we need to do something with it in order to transfer it to long-term. The more things we do and the more often we do it, the more likely we are to transfer it to long-term memory. So there are two ways of doing that, and they kind of work together. One is rehearsal and the other one is retrieval. What they really mean is practice, basically. Rehearsal is practice. So we're bringing things out of long-term memory, that's retrieval. Doing something with it in the now, with using our working memory and short-term memory, and then popping it back into long-term memory. And that's important. And why retrieval is important is because we learn where the information is stored, and we develop tweaks and sort of little ways of going to the right file and retrieving the information quickly and effectively. So retrieval in itself is a skill, being able to quickly find the information, but we don't develop it just like that. It's that the repetition of retrieving that memory, retrieving it again and again and again, that makes the pathway to that file easy and effective. And effectively, you can do it instantaneously. But it's really important to understand that once something has been taught, and even if the children walk away and they can tell you what they've learned, they might not remember the next day or the day after. And for some children, especially those with learning needs, that whole process might be compromised by something. So they might keep things in their short-term memory, but they need extra retrieval and rehearsal time to develop the pathways. So I hope that makes sense. Long-term memory is both, it's got three other sort of types of memories within it. It's procedural, which is automatic. The motor things riding a bike is one of them. Things that we do without consciously trying to remember how to do. That's the semantic memory is related to fact and knowledge, and that is shared among people. For example, the capital of New Zealand is Wellington. That's shared, and that's a fact. And then episodic memory, which is a personal scene, and it's personally relevant. And in this case, different people will have different memories, episodic memories of the same event, because that is tied in with emotions. Why I'm mentioning this is because a good lesson and a good learning experience will appeal to at least one of those, or two. If we can get all three of them, that's great. But if we can form memories in the procedural, the semantic, and the episodic memory, then it's just more ways and more places where it can be stored. Therefore, the learning is deeper and more meaningful. So And this is where the multimodal comes into play, why I'm promoting this multimodal way of learning. And I realize now that 50 minutes have just passed and I have a lot to cover. All right. This is from Ken Robinson. We vastly underestimate the capabilities of children's ability to learn. So what we give them is sometimes a lot less than what they can handle. We create scopes and sequences and ideas of when and how they should learn something because of their age. But it is my belief that we have to expose children, young children, to all sorts of ideas. It doesn't mean we're going to get them to do math like in year 5 and start multiplying fractions. No, it actually starts with language, and you'll see what I mean in a minute. So here's the start of fractions. So the first bit in the lesson, so I'm going to go through this now as if it was with children, but I'll stop and talk about it for a bit. The first thing that I would do is ask what they know about fractions. This could be 5-year-olds, even 4-year-olds, because it's a language-based thing. So they might think, oh, it's a pizza, it's halves, it's wholes. Somebody might say, oh, it's when you have to share with your sister. And because we're in a multimodal way, the first thing that I would do, and what I'm going to do now is actually just swap my screen because I'm going to show you something. So I'll be sharing this now. All right. So the first thing I would do is I would just get my babies, children, to go, well, here we've got an apple, well, 2. I'll just start with 1 first. So they give me all sorts of ideas about what a fraction is. Now we'll talk about it. So then I'll go and I'll chop off a little bit like that. And I'll ask them, well, is that a fraction? And they might say, well, maybe. And then they might say, it's not fair. I said, this is yours. You can eat this one. Well, that's not fair because you have the bigger part. So just that language, that negotiation of knowledge, what it gives me understanding of where they are, what their thinking is, and we're developing a common language through which to develop the next bit of the lesson. So then we'll have a chat. This is not fair. Well, okay, we don't like that one. That's not good. It's not fair. So you can see that what we've just introduced is fair and sharing. So those are very important. So then I'll go and I'll sort of go try to get the middle. And I'll go, well, how about that? Is that a fraction? And then, oh, well, that's a little bit more fair. And yep, we can agree that this now is a fraction, and I might proceed, depending on how many children there are, I might proceed to do, to cut more. And then we'll talk about, well, what do you call this? What is that? And it's like, oh, this is the whole apple. So how much of the apple are you getting? And they go, I'm only getting half. What if we're 4? Can we get 4 pieces out of it? And we're just negotiating understandings and bringing up the terms that we actually need to use. So I'll take this away. We might use this to sort of share and actually eat the apple. So that's the multimodal aspect again, and the multisensory. So I'll be sort of swapping back and forth between these 2 screens. So here we are. We've just sort of understood what we're trying to talk about. What is a fraction? Is this a fraction? Not really. Is this a fraction? Well, kind of, because it's fair. Is this a fraction? So showing it in different ways, And now we might go and really introduce, oh, that's a fraction. Let me tell you about the story of fractions. The word fraction comes from a Latin word, frangere, and that means to break into pieces, or fractionem, which is it's a breaking of something, or fractus, which is broken. And in English, we have words fragment, fragmented, and fragile that have the same root. So we can see that there is connection there. And I might ask them, have you ever had a fracture? Have you ever broken something? And they, oh yeah, I broke my arm. So what we're doing here is we're starting to connect this mathematical concept to their life and to their world, which is important because then they can have a personal connection to it. And down here, you'll see that I'll have, what are we doing here? Well, we're actually talking about a little bit biology. They might ask, why bones break, and might have a conversation about that. It might stir their curiosity. They might share something. Oh, have you broken an arm? Oh, I've broken my arm. Oh, I've broken my leg. So there's that sharing of personal information. And of course, the storytelling aspect. And then for this, I would actually bring out a picture, probably maybe a personal picture of mine to my class, because they know what my family, because I talk about my family, and my family is made up of mom, dad, and 2 children. So I might bring out a picture and say, okay, well, this is my family. It's made up of 4 people. So I'm 1 out of 4. And, then we go around and we ask, well, how many people are in your family? Oh, we've got 5 in my family. So I'm 1 of 5. And so on. So we'll have the discussion and maybe share some photos and share some personal connections. They might say, oh, does my grandma and grandpa connect or count as part of my family? They might say, well, if you want to, that's fine. So then we'll kind of steer it towards, this is a family of 3. This here would be a family of 3. This one is a family of 4. So trying to really set that foundation of understanding fraction families. And then we might move on to that. And this is, again, you'll see these numbers here. I forgot to mention these numbers here actually denote how many modes we are using. So this is our 2nd mode of personal connection to this new concept that we are covering. So then we'll introduce fraction families. And I'll swap my screen just so that I can demonstrate what this looks like. Oh. Okay. So I'll bring something out and I'll say, oh, well, in this family, there's only 1. Well, this is the whole family is just 1. So we'll call this whole. And what I do, there's no notation at the moment whatsoever. I will just write simply, this is the family of whole. Do you know anyone who's just by themselves? And they might say, oh, a neighbor, might say, my grandma, my grandpa lives on their own. And then you go, well, and then here is a family of 2. There's 2 people here. And do you know what the family name, or the surname of this family is? Well, the whole tells us there's only 1. So this is the family of halves. And that tells us that there are 2 members in this family. And then we'll move on and we'll do the same. So with the next one, just like this. And it's all, well, there are 3 members in this family. So how do we know? How can we tell somebody that this is a family of 3? We call them thirds. And I'll continue. So I've got materials right up to the 10th, and we'll continue doing this exercise. And if you're doing this with a 5-year-old or a 6-year-old, we might just stop at doing this. That's it. We don't need to get into that. That's highly symbolic, and we haven't prepared the mind yet. It's too big of a jump. So what I would want to do with them now is I would want them to practice this. And how do they do it? Well, I'm going to move this away for a minute, and I'll show you what they would be doing. So I would have material out, and I'll have these. Oh, maybe we have moved on. Maybe I won't use these ones at the moment because they're just, they use the 1/7. And I'll just possibly just go back to my presentation because that will keep me on track a little bit better. Okay, so here's a family of wholes, halves, and there are 3 in the thirds, so we might write that as well. And we'll just carry on doing that. When we come to fourths, they might start to understand that there's a pattern to that. They might go, oh, fourths, and it's, we can also call them quarters. there's fifths, and so on. So I've just popped them all in, the eighths, the ninths, the tenths, and that's it. Now that we've given the language, so say that they go away and they've done this part and they really, they're solid, their knowledge is solid about this, then I will bring them back in and I'll go, children, I'm going to show you now a mathematical way of writing fractions. You know, we've used words, but now we're going to write them down. So there's a picture here of a Roman school, because we talked about the word fractions coming from the word from Latin. And there is a wax tablet, which children used in the olden days in Rome when they were going to school. So I might start with a story, and I might say, well, let me tell you. Do you remember when we talked about the word coming from Latin? Well, it comes from the Roman Empire and the city of Rome, and children went to school and they used these clay tablets. We might talk about the history. Other ideas might come up. We might even make a wax tablet or a clay tablet, because they're quite easy to make, and they can also have a go at doing that as part of this process. But I'm going to go and tell them the story of how children came up with the fraction notation. Is this a true story? No, it isn't. It's a bit made up, but it is based in history. So I'm going to say, well, do you remember that you're 1 out of 3 people in your family? You're 1 out of thirds. So how do you write that with using math? Well, sometimes we use a different, well, out of gives us a bit of a clue. So the children in Rome, when they went to school, they would write, I am 1 person, fractus, out of, so a fraction, out of 3, 1 fractus 3. Oh, can you imagine if the children had to write 10 or more of these fractions? Would it be tiring? Well, of course it would be. So the teachers went to their teacher, and the children went to their teacher and said, teacher, can we just use the first letter? Can we just say 1 fractus 3 and understand that that means fraction, or 1 out of 3? Of course, the teacher said, that's really smart. And then they kept on writing and they said, teacher, you know, can we write just 1 line from the F3? Can you see where this is headed? And the teacher said, well, yes, of course you can, because we all know what it means. And then a little later on, they said, teacher, can we write just the first dot where the line starts and the second dot where the line ends? 3. And we know that means fractus 3, 1 fractus 3. Of course you can. Now, I'm going to make another connection here. In Europe, the division sign is, so this is our division sign, but in Europe, the division sign is just 2 dots. And we know as adults that 1/3 is the same as 1 divided by 3. So there's that connection being made here, but they're not aware of it yet. So let's continue. Once after I've told the story, they might go, that's funny. Let's start writing our fractions like that. Or let's start looking at how we write fractions. The continuation of the story goes that eventually they worked out that this is the best way of writing fractions. So we get to the notation of 1/3. So you being 1 out of 3 people in your family, we would mathematically, that's what we would write. You are 1/3, 1 out of 3. So that's that part. And then what we would do, we would certainly start looking at matching or writing, drawing the fraction and writing the symbol and the words. So their activity that I might want them to do is basically, I'll just remove that. I would get them to trace And this is an indirect sort of objective here. By tracing or cutting out, we're also helping children develop their fine motor skills. So by doing what I'm trying to do with every activity is see how many other things can we actually put in there without having to do something extra because we're time poor. So we might say that this is 1/3, and I might even write 1/3 here in words. Remember, language is the way in. And at this point, comes my lovely little material here. Came a bit too soon before. So what we might do is start matching. So, we have 1/5 here, and the children can play a game, a matching game. They can play I have, you have. So, we might hold up I have 1/2, or who has 1/3. So the person holding the 1/3 will say, oh, I have 1/3, and so on. So there will be, or a memory game. But this is an independent practice, and this helps that retrieval and rehearsal process to move things into long-term memory. Eventually, there is, let me see what I've got here. Okay, so what I would do here, depending on the child or the children, I would just stop. I would stop so that they have a chance to practice this idea here. And if they get really good with this representation, I might say, wow, you know how we've been looking at fractions as circles? Well, how about we look at fractions as a line? And we might just have a line and figure out what half is and what matches. And we might have a third set of cards that they have to mix and match. And then say, oh, you know how we've been looking at fractions as circles and lines? Well, let me tell you that we can actually look at them as shapes as well. So rectangles, there's squares, there's rectangles. So then there comes the other added layer of stuff that they can do with it. And then, so this was just unit fractions. So they can do this with unit fractions. My set is mixed here. It's got 2/3 as well. So we call these unit because they have one, they're just one of the fractions. So there's a term there called unit fraction. And then say, well, you know that we've been learning how to say that there is one person in that, or one member of that family. Well, how can we say that there are two members of that family? So I might bring out my thirds, and we might say, do the same, trace. And how do we write that? Well, here's how we write that. We write 2/3. And then I'll write in words as well, 2/3. Okay, this is just laying the foundation with language and connecting a material or a pictorial representation of the fraction with the symbol and the language, but also making a personal connection that is meaningful to them. So then there's my other set of cards that will include more than just the unit fractions that they might want to just take with them and play another game. On top of those cards, I also have sort of these activities that will go with them, where they actually have to match. Now we start doing activity task cards. So they'll say, they'll pick this one up and I say, match all of these fractions. So how many halves, how many ways can we show halves? Well, as a line, as a piece of a shape, as a circle, as a symbol. So there are many ways. So, find all the ways you can show halves with all of those cards. Find all the ways that you can show thirds, 1/3. And then there is sorting fractions. So this is, what are the fractions as a number? This one I won't introduce yet. This is, but I'll talk about it at the end. Fraction in words, and then later on, when they're ready, when I feel they're ready, we might be doing some ordering of fractions. Ordering is easy in terms of if they use materials, because they can see which one's bigger, which one's smaller. So it's developing that that sense of what they do, how they relate to each other. All right, so that's that. Let's see where we're at in our presentation. Oh, sorry, wrong screen. Okay, so we've told the story. This one is related to the symbolic notation. So there's another approach that we can use, and using words, we'll say, well, this is one member of three of a family of three, 1 out of 3. And then you just watch what happens. We can also say that it's 1 divided by 3, though I might not introduce that to year 5 or 5-year-olds. And then all of a sudden, all of those words have been replaced by a line. So we've got 1 out of 3 without the words, but the line that represents the words. And I've made that connection to the division sign. And usually in a fraction, the bottom number tells us the family belongs to. So the Smiths or the Joneses, and the top number tells us how many we are looking at. So here's Mr. Jones, or Mr. Smith, sorry. He's 1 out of the Smiths. And because they're our neighbors, we know that there may be 4 people in that family. So he's 1 of 4, but he's 1 of the Smiths. The top and the bottom, they have a name. The bottom part, because it gives the name to the family, it's called the denominator. And I want to just draw your attention to the word, to the bit here. It's called nom. That comes from the Latin word for naming something. And the top number that tells us how many in that family we're working with or looking at, that's called the numerator. And that sort of looks a bit like the word number. When we look at these, I would ask the children, does that a word sounds or looks similar to something you already know? And I might say, oh, yeah, that looks like number. Oh, okay. They might not know at all, but I'm going to give them that information. And then here's the information. And numerator comes from the word numerare, which is to count or to number something. And denominator comes from to denominate, to name something. And the noun part of that is nomen, which is the name. All right, so I think I've reached the end of the introductory lesson. And again, if I were looking at year 5s or 4s with this lesson, I would go right through and give them everything. If I was doing it with a 5-year-old, I would probably work on this, break this up in about 3 lessons, because there's a lot to take on. And we want the steps to be a little bit smaller. The older the child gets, the more life experience they have and the more connections they can make to a lesson. The younger they are, they just haven't got the life experience to connect to everything. And also the attention span is shorter. So anyways, what are the essential elements of a lesson? Well, engaging the prior knowledge, what they know. And also it's about identifying what they know, but also what they misunderstand about something, any gaps, any interesting connections they might be making that you've never thought about, and attitudes towards what you're doing. So if somebody says, oh, I hate fractions, it tells you something about it. It tells you that we need to work on attitude first, or we need to change that, the way we approach it, so that the attitude has a chance to change too. But for me, misunderstanding is one of the biggest one, and attitude is very closely up there as well. I would do a warm-up activity because this was an introductory lesson, there was no warm-up. But if we are going to head into, say, adding fractions now, I would go through naming fractions, because that's information they need to have immediately available to them. So bringing it out from long-term memory into short-term memory so that we can start working with it. Transferring knowledge is another one. So where else in your life have you seen it? Why is this important? Why should we know this? Why, where do we use it? what does it mean and how is it relevant to us? So that's transferring of knowledge. And when you talk about fracturing an arm, that's relating it and transferring to something else. When we talk about 1 out of 3 people, we might be talking about that. We might even be talking about things, well, today, there's 30 of us in the classroom, but 2 of us are away. So how can we say that as a fraction? Well, 2 out of 30 are away. Great. So making that connection. Vocabulary is so important in oral language because it's about negotiating the common ground in the language we're going to be using to explore these concepts. That's really important, is to have the language that we have in common, to establish that commonality. Storytelling to me is so important because it engages the imagination and emotions. And if you can recall, when we looked at memory, one of the memories, the types of long-term memory, was episodic, which was remembering a scene that involves emotions. If we make that available to them as a scene, a complete scene with emotions, they're more likely to remember it. And just one other thing here, the brain has 2 very, very important parts when it comes to perception. Big parts, I guess, that one is a huge part of the brain, perceptual brain, is dedicated to face recognition, which is important to us as humans. We're very attuned to human faces. And the other one is scene recognition, or so a complete scene, like your house, doctor's office, the library. So we remember scenes, that sort of visual picture, that snapshot of a scene. So we want to create that for children, that sort of snapshot that they can. Do you remember when we cut the apple? And then immediately that can come to mind. Do you remember when we played that game? And that would be a hook to bring that out. A hands-on activity, I highly, highly recommend hands-on. Getting the children to cut, I would get them to cut these out. Two reasons. As the fractions get smaller, they get to actually see what happens to them, and how they have to manipulate, and how you go from cutting out a circle or a square to cutting down little bits of something. There's more concentration that's required, but also there's that they can start to distinguish what is that nuanced distinction between a 9th and a 10th. The difference is not very big. And then sometimes the children can't cut because they haven't got the skills. So in that case, I might help them a little bit, or somebody else might help them. They might have to try something first, the bigger ones first, and I might help them with the rest. But still getting them to have that hands-on. Having a guided activity, so that is before I give them something to do on their own, independently, I might start them out. So if it's a cutting activity, I might say, okay, let's cut out a whole together. Let's cut out the halves together, to show them the process. And once they cut out the half, pasting it and writing underneath 1/2, and then 1/2 in words, so that becomes the baseline of the expectation of what they have to do. And then they can go off and do that on their own, finish it off on their own, but they've got the model that we've done together. And then, of course, reinforcement activities that are done independently, where they practice. It could be these games that I've shown you, could be completing the activity that you've already started. So those, to me, those are the essential elements of a lesson. Some do's and don'ts that I very much stick to. Giving the language first. In terms of fractions, having a sturdy set. So I've got a set of plastic fractions, but you can make ones, and there'll be another slide with ideas later on. Or cardboard, it could be cardboard that you cut it out of, but it's just sturdy so that they can work with it. And the next point is have only one variable and concept at a time. So you've noticed that all my fractions are red, and I will keep them like that for a long time. And the reason being is that if they're not all the same color, so we're varying the color now, we're adding a second variable, it can become a matching exercise. And instead of going, oh, what's the difference between 1/8 and 1/9, they go, oh, 8ths are blue and 9ths are yellow. So they start matching them up, and then they, instead of looking at the at the fraction, how big it is, and comparing it to the others, they just go for the yellow and they match it. They match the fractions. So that comes into the next one, which is the same color. I would have children make their own set. So this is something, it's an ongoing activity that I would have them do, because as we progress through the scope and sequence, they will have to use them to do addition, to do subtraction. So if they have their own set of fractions, then they can easily do that. There's always one, as I said, a very sturdy set. So if theirs is not precise enough or doesn't work, they can go to this other one. Cut, label, and write out the equivalency. And we'll see it on the next slide what that means. Write it out in words, using that language, exploring other shapes, making a game out of it, and yeah. I've shown using other shapes. That's repeated. Some of the don'ts: don't use color in activities, not to begin with, because there's nothing in the coloring that gives them a sense or helps them distinguish or really understand what is happening. They're just coloring in a shape. When later on, if they've already got the concept, absolutely, worksheets, whatever, they have their purpose. But we're trying to, and you'll see this, the last point, we are trying to develop their qualitative and quantitative concepts of fractions. And how do we do that? We do that with our hand, and we do that by being able to discriminate between fractions and how they relate to each other. Don't use different colors for each fraction families, and don't include more than one concept per sort of activity. The older ones might be able to do 2 things, but I would really keep it to 1 until it's really, really firm, until they can do it with their eyes closed. I really, especially when it comes to fraction, mastery is key, absolute key. We should not be hurrying through this activity or this learning. This is what I would have them do in their books. They would cut it out, they would label it. And this is an example. It's a digital one that I have made as an example, but it's not what you'd see in a book, of course. But I would want to see a close approximation of this, because this also becomes their reference. If they don't remember and they need to retrieve and they can't, they can have this resource they go to, and I say flip back to your fraction family display. To remind yourself, and then they go back and they don't even need to look, they only need to flip back and glance at it and go, right, I remember. All right, so here's some examples of work that I would do with children. So this is in their own work, they can do this color thing because they're not going to be working with it, but it can be distinguished because they're already cutting out and labeling and doing all sorts of things with it. So in this sort of activity here, no problem, use colors, be creative. No problem there. There's a little booklet that is being made here with cookies. So same concept. We're writing out the words and having it as a reference. Here's another way of doing it where we're looking at common fractions as opposed to unit fractions and showing what does it really mean to have 4/6. And here's a plastic set that I had made before. Using those sort of L-shaped envelopes that you no longer want or need, and it's just cutting one it's a bit sturdier, and it can also see through them, which can make some of the activities a little bit easier. So that's another idea. Right, what multi-modes have we used in this one lesson? We've engaged the imagination, and that comes with an emotional load. Something fun. It could be, it's interesting to hear about how other people lived. There's an appreciation for what has come before, and just like fractions have had a journey through history, they also have a learning journey, and they are learning the same thing that children in Rome learned a long time ago. Storytelling is about oral language and vocabulary development. There's a lot of stuff that you can bring and talk about, so supports that aspect of learning. Connecting to what's familiar to them, so always asking them to say, what does this mean to you? How is this connected to what you know? Have you seen this in your life? So making that connection, making the connection between language and symbols, language first, symbols after. The symbolic representation of mathematics is something that you need to learn. It doesn't happen spontaneously. Children learn oral language spontaneously without effort, but they need to learn to be taught to read and write. They need to be taught math and the symbols of math. And what I always go back to on here, just like we teach children the sounds of letters, we must teach them the words that go with the symbols. It doesn't just happen. It's the symbols themselves are just a visual representation of a lot of knowledge. We're always doing, always making, we're feeling things. That's with our touch, but also with our emotion, and making judgments. You know, why is 1/9 smaller than 1/7? Well, they go, well, I don't know. So making judgments about what you are seeing. Some indirect skills that come out of this, it's fine motor skills, cutting and pasting, vocabulary, collaboration, if you're doing this in groups, because they can negotiate meaning between the children and sharing personal experience, and seeing what other people's experiences are like. And of course, discussion is always big. Now we're going to head into what my sequence is, what sequence I use. But before we do that, I cannot stress how important it is to spend a lot of time doing what we have done up to now, because they need to understand that fractions don't just apply to circles or pizzas or whatever. They actually apply in real life as well. So there are lots of activities that we can do. And I've got a couple of ideas here that have worked for me. One is I've got an origami boat, folding paper. And if you look at origami instructions, it's, fold in half, bring the third over. So there's a lot of that language, and paper airplanes falls into that category as well. When music is another, you've got a musical child who plays a violin or plays a piano, a whole note, half note, quarter note, all of that is fractions. What is that? A whole beat, half a beat, and so on. What does that look like? What does that sound like? Let's do the beat. Let's see what that feels like on our body. Another activity that I've got there is making snowflakes. And to challenge them, I would say make a snowflake that is missing a third of it. So the holes have to represent a third. So, how do you do it? Well, you'll fold it. And I think I can show you. I've got some paper to show you. Folding paper, of course, that's right there. You can hand them a piece of paper. What does a quarter look like? Well, here it is. The connection there is, and I'm going to actually stop and do it with you. If you've got a piece of paper now, it's a good time to bring that out. And I think I have misplaced mine. Okay, never you mind, because we can do it anyway. All right, so here's my piece of paper. So I'll just cut that in half. All right, so I'll pretend that this is an A4 piece of paper. So here's my full piece of paper here. Well, can you fold it in half? Sure. So ask the children, how many ways can you fold it? Well, I can fold it this way, or I can fold it this way. So if we fold it this way, have we got halves? Well, are they equal? Is it fair? Yeah. What happened if we did it the other way? It would still be fair and equal. And then, we can go from here. We've got half. Here's our half. Can we make quarters? What other fractions can we make here? So, if we fold it in half again, we've got quarters. So now think about this concept. A quarter is a half of a half. When you go and multiply and you introduce multiplication, a half of a half is actually 1/4. That is the connection. But then when you teach this, you can actually remind them of this. This is exactly what we're doing. Then if we continue and fold, let's fold a quarter in half, and then I'll get them to guess how many shapes, how many, shapes have you made if you opened up the paper. And some of them might be able to think that they've just doubled it, but some of it might not. And they open it up and they go, oh, and they count them. One, two, are they all equal? Are they the same? Yes. Is it fair if you have this rectangle and somebody else has this rectangle? Yes, because it's fair and equal. What have we just done? We have taken 1/4 and halved it. Half of a quarter. What is that? It's 1/8. And this is what we've got here. So that sort of sets the scene for this. And if I were to teach multiplying a fraction by fraction, this is what I would do. It's always fun to go, well, what if you don't do half? What if you do a third? And you go, well, let's see what happens if we do, a third. So we've just made 6th, by the way. So we've taken, not 6th, we've taken a half times a third. So now we've just got 6th here. So that's my hands-on activity. And then guess what? Once you've made the creases in the paper, they can actually take their paper and glue it in their book and start and label it. Label, this is 1/8. I know my paper has got extra folds in it now, 1/8, and so on. And then they can even say, well, there's my half. So we can say, well, that's half. That's what the half was. So playing with it in that way. That's another little activity. Let's see what we've got next. All right. Snowflake. I'm not going to do the snowflake because we are sort of running out of time. So this is being the progression after we've done all that. The paint. Mixing paints. What happens if you start with primary colors and you add half blue, half yellow? Do you actually get green? So thinking about that also in terms of art, you can introduce the rule of thirds. That's a well-known art technique of breaking up your paper, your canvas into 3 equal parts, and each part has its own role. Where's your focal point? So that's the art part of it. Now, fraction equivalence is what I would do next. And equivalence is so important. Equivalence is actually a foundation skill, much like place value for numbers, for whole numbers. It is so important. I cannot stress just how important this is. And I would spend a long time until they can actually pretty much say that, another way of making 1/3 is 2/4, 3/6, and so on. These are some of the activities that you can do. So basically up here, you have equivalence of a whole. Here's how many ways can you make a half? These are all the ways you can make a half, a third, and you can do the same for fourths. But so important. And eventually, as they go and they grow up and go through their years and they learn their times tables, they start to make connections that there's a pattern to it all. So that's that. Another way that we've seen equivalence is using these strips. And I want to stop and do an activity again with this one, because you can make your own strips, which children can use to work out equivalence. So what I've got here is I've got a little strip of paper, and I'll get them to fold it in half. So here we go. We've got a half. So essentially what we've got is we've got a hole here. So I can label that as 1. This is 1/2 and 1/2. And I will get them to think about, how do you make thirds? How do you make thirds? And they might try different ways and different things, but eventually they'll come to realize that you can sort of negotiate thirds by doing something like this. Think about the judgment skills and the fine motor skills that are being employed here, hand-eye coordination, all of that, that will help you in other areas of their life, like writing and reading and all sorts. So I'll label that 1/3. And I'm going to do another one. I'm going to do the fourths as well. And I actually get them to do 7ths and 9ths. Sorry, I think my family's getting out their dinner. If you hear some noise. All right, so here are the fourths. And I'm just going to stop here because if you line them up and you start to see what happens, you can see that there's a fold that lines up with this fold. So you can say, well, what's the same as 1/2? What's the same? 2/4 is the same as 1/2. And now imagine taking this information and start ordering fractions. You know, if you go 2/3, so here's our 2/3. You know, which one's bigger, 1/2 or 2/3? Well, it's right there for you, available to see. And at this point, I might start introducing these symbols as well. And the story I use is the alligator. You might know this already. The alligator mouth is alligator is very hungry, or crocodile is very hungry. He's always opening his mouth towards the biggest thing. So in this case, I would write 2/3 here and 1/2, 2/3, 1/2. Which one is bigger? Well, we can show it like this. So there's another symbol that we can use here. So that's this activity. And what's next? What I wanted to show here is that what we've done so far is a foundation knowledge, and we probably with young children. So if we're looking here at 5-year-olds, 5 and 6-year-olds, I would spend 2 years on this. All different ways of doing it, bring it out of their memory, because you don't do this every day or every term, you know, but really getting this knowledge down so it's automatic, is into that procedural sort of aspect of memory. The next thing that I would do is add fractions. So add unit fractions, 1/2 plus 1/2. And do that. What happens then? This is less than a whole, or less than, because there's an added aspect, another layer that will come in if you're not using, if you're using fractions that will take you over a whole. So now we're introducing mixed fractions. So 3/4 and 2/4, that's 5/4. Oh my goodness, 5/4, that's an improper fraction because we have more than a whole. What can we do? We need to show that. So here it is, that one. So we've added first. Now it's the next step of introduction to mixed fractions. So far we're just adding. Next thing, we're going to be subtracting. What you see here is you see 3/7 take away 2/7. What are you doing? Well, here's my 3/7. I'm taking them away. That's what the sign tells me to do. This is a command that says take away. So here I am. What's left? 1/7. Now we just move that to what's left. So you can see that we're doing a lot of this sort of moving things around, manipulation. Multiplying now. I want to just say that in the first, actually we'll get to that in a minute. So now we're taking and multiplying by a whole number, and that's important. We're taking 1/2 multiplying by 3. Well, that's 3/2. So here they are, 3/2. Well, if we write that as 3/2 as an improper fraction, so we need to reduce. So here we are doing that reduction like that. This is why I said it's important for children to have access to a sturdy set of fractions, or have their own set that they can work with so they can manipulate. Again, this is division. I really want to take some time to demonstrate this because this is so cool. And people put that in the too hard basket, but it's so not hard. So I'll show you how I do this. All right, so let me just remove that. All right, so let's say I have a third and I need to divide it by 2. What does the word divide by means? Well, it kind of means sharing, doesn't it? Sharing equally. Where else have you heard that? Fractions, right. So we're again, division is about sharing equally. So do you think there is a relationship between division and fractions? And of course there is. We know there is. So I have a third of a pizza. I can put it into context. But you know, there's my brother and I, and we're really hungry. What's a fair way to share it? So what I have here, I have my brother and I. Well, I really need to break this up into two pieces. And if they know their equivalents, they will know that a third is the same as 2/6. But if they don't, I'll go, well, what kind of fraction do you think will become if we cut this in half? What will happen to it? What kind? Do you know what kind? And then, oh, maybe we can break it into fifths. And you can try it out. Fifths won't fit. Yeah, can you do eighths? I don't know. And then eventually we might decide on 6. Perfect match. There we go. So now we have 2. We can share equally. And here is 1/3 divided. So it's what we've got is 1/3 divided by 2. And the answer is sort of what one gets, right? Each person will get 1/6. And if you know, and if you can think back to your own primary education and the rules with division and fractions, was invert and multiply. So basically what we've learned to do was this, right? And then multiply this way. And what do we get is 1/6. But we can teach this, of course, but it has no relationship to what we're trying to do. And if they see it, then you go, oh my goodness, of course, that's what you're doing. You're inverting and multiplying. And why do you need to do it? Well, because you need to share between two people. So that's that activity. All right. Here we go again. Right, so then we go to, so here is where I would introduce decimal fractions, and better known as decimals, because when we break a whole number into 10 equal pieces is 1/10. And that's when you have things like, the 0.5, that's 5/10. But I'm not going to get into that because that's a whole other sort of area that I don't want to deal with. It's big. Next, it's comparing and ordering fractions. This little thing here, you can introduce it anywhere in your sequence, but I believe it's important to do to compare. So what I've done so far up to this point is I've kind of taken you through what a child should know by the end of year 4. This isn't hard at all. We're scared of fractions because we've been taught to be scared of fractions, but it's not hard, especially when you start cutting things up and having little pieces to play with. And then what I want to take you to is what comes next. So the next thing in the progression would be addition of fractions with different denominators. And there's something they need to know, and this is why I said by the end of year 6, because then before we ever do this, they need to have some understanding of multiples, common multiples and factors to be able to do. But I've got an activity that you can do that even before if you want to add fractions with different denominators or compare fractions with different denominators. And if I've got time, I don't want to go beyond 8:30 because that would be long. Reducing fractions, it's part of that equivalence. So if you end up with 8/12, you can reduce that down to smaller fraction. Subtraction would be after that. Multiplication of a whole number by a fraction. So the opposite, we did half times 3. Now we can do 3 times half. And that is where fractions of quantities comes into play. I know that we ask children quite early on to give us fractions of quantities, and they can do it orally and they have a bit of an understanding, but it's multiplication of a whole number by a fraction that gives you fraction of quantities. Next one is multiplication of fraction by a fraction, division of a whole number by a fraction, and division of a fraction by a fraction. And those can be demonstrated in the same way. If you'd like me to do this demonstration, I'm happy to do it if you're happy to stay, basically. And this is the end of the presentation. Oh, here we go. That is the end. I'm so glad that I didn't go to 8:30. That's amazing. So what I'm going to do is I'm going to stop the recording, and I can take questions. So that will go